Okay, in this video I'm going to do some example problems from the topic of counting, otherwise known as combinatorics. And in this first problem we're given a set A that contains, let's see, 1, 2, 3, 4, 5, 6, 7 elements, and we want to know how many permutations are there of this set. And so permutation is a rearrangement of the elements in the set. We can count the number using the product rule, and we need to build a permutation one element at a time, and we're going to multiply the number of ways of doing each step together. We've got 7 steps for 7 items in each permutation, and the first step we can choose from amongst all 7 elements. The second step, because we don't repeat elements in a permutation, there's simply a rearrangement of the elements here. 6 choices, then 5, 4, 3, 2, 1, and this is 7 factorial. And so we can say that if the size of the set A is 7, that the number of permutations following the general formula is the size of that set factorial, which in this case is 7 factorial, which comes out to 40. I calculated that earlier on my calculator. Okay, so there's a detailed explanation. This is using the counting principle. And this is the calculation simply using the formula for the number of permutations. Okay, hope that one's clear. And I'll move on to the next example. We've got a set with 3 elements in it, a triangle, a square, and a circle, and it wants us to write out all the subsets of B. Well, the set of all subsets is called the power set, and this is our notation for the power set. And so I'm going to go ahead and call this set the power set, and I'm going to write it as a set, and inside that set I'm going to include all the subsets of B. Okay, and we're going to start with the empty set, which is a subset of every set, and then we're going to move on to the singleton subsets that each contain just one of the elements of the set. Then we're going to move on to subsets that contain 2 elements, triangle and square, triangle and circle, and here we have square and circle. 1, 2, 3. I think there's just 3 of them. And then finally, the subset that contains all 3 elements. That is, the set is a subset of itself. Every set is a subset of itself. And there's all the subsets of B. These are the subsets here of length of size 0. There are 3 of them of size 1. There are 3 of them of size 2, size 0, size 1, size 2, and size 3. And there are 1 plus 3 plus 3 plus 1 of them altogether, which comes out to 8. You'll notice the 1, 3, 3, 1 is one of the rows, the third row, in fact, in Pascal's triangle. Okay? So that the number of subsets of B obeys the general formula for the number of subsets in an n-element set. Well, the number of subsets in an n-element set is in general given by 2 to the n. In a set of n elements. And so in our case, the size of our set is the size of P of B is 8, which is in fact equal to 2 raised to the 3rd power, which is the size of the set B. Okay? And so it does satisfy the general formula. There are 8 elements in it, and so it works. How many 2-element subsets does B have? It has 3 of them, And the next part it says to simply count the number from the part A above. It has 3 of them, and show that the number of 2-element subsets of B obeys the general formula for the number of k-element subsets of an n-element set. And the number of subsets from an n-element set is given by the number of combinations, the CNKs. These are the ones that don't include order, and that's we're talking about subsets, so order is not included. So this is n factorial over n minus k factorial k factorial. And here we have n equals 3 and k equals 2. So we have 3 factorial over 3 minus 2 factorial 2 factorial, which is 3 times 2 times 1, all over 1 factorial, which is 1, and 2 factorial, which is 2 times 1. And you see that this does equal 3, and it works. Okay, so it's very important to be able to look at something you have. We have 3 elements here, and to be able to plug into the general formula with the right relevant values and to reproduce that number sort of in detail here, as I've done. Okay. Let's move on to another problem here. Actually, I'm going to put this one on a new video, and I'll stop here. Hope this is helping.